All right, this video is going to be about tangents. And a tangent is basically perpendicular to a curve. So that means it touches the curve at one point and one point only. Now, if you have a circle, well, I'll get into the next problem. For now, it's perpendicular to the curve. It only touches the curve at one point, and a tangent is always a straight line. So here's an equation for you. How you want to solve this in this particular problem, they ask you to find the points on this curve where the tangent is vertical. So the tangent is a straight line. Vertical means straight up and down. So you want to find the points where the tangent is going to be a line going straight up and down. So all you do is you go to a graphing calculator website, or if you're taking the test, it'll be built into the test, your graphing calculator. And you just type in this equation, like Desmos is a good graphing calculator site. You type that in, and this is what you're going to see. It's going to automatically graph this for you. So I did that. I typed that in, and then I just copied it down here so you could see it. Now, vertical means that it's going to have to be touching the circle at the very far right edge and the very far left edge of the circle, which on your graphing calculator is real easy to see that it's that point and this point. Those are going to be lines that are perfectly straight up and down, tangent to the circle at the far right and left edges of the circle, and they just happen to be at the points 5, 0, and 1, 0. I don't really have room to write it any closer to the point, but that's 1, 0, and that's 5, 0. If they would have asked, what are the 2 points where the curve, where the tangent is horizontal, then you would have went to the very top and the very bottom, and it would have been that point, which looks like it's at 1, 2, 3, 4. That looks like it's at 3, 2, and this one is at 3, -2. So if they want horizontal, it would be those points at the very top and the very bottom. But in this particular question, they wanted vertical, so it was those 2 points. All right, the next one's a little bit trickier, but basically the same. You still want to use Desmos. They give you a little bit more complicated of an equation, but it's just another equation of a circle. So you type that in, and this is the circle you get. Now they want to know the equation of the tangent line, and the tangent line is going to be diagonal. It's not going to be vertical or horizontal. Well, this is going back to Algebra 1, but the equation of a straight line is y equals mx plus b. Y equals mx plus b, where m is your slope, b is your y-intercept. So if we could just figure out what slope and y-intercept are, m and b of our tangent line, we could plug that number in for m and that number in for b, and we'd be done. That'd be our answer. So this is the key, finding m and b, the slope and the y-intercept of a tangent line at the point 2,5. So that's the point 2,5 right here. So what does it mean to be perpendicular to a circle? It means be perpendicular to its radius at that point. So the radius goes from the center to that point. So where is the center here? Well, it's the opposite signs of your equation. It's +1, +3, but you don't really even have to look at that. On Desmos or a graphing calculator app, you could just look at the circle and you could see that's the center right there, because they'll have all the grid lines on there. So it'll be pretty easy to tell that's the center at the point 1, 3. So you connect that to 2, 5, and that's your radius. So how do you find the equation of this radius? You need to find the equation of the radius first in order to find the equation of the tangent that's perpendicular to it. So how do we find the equation of the radius? Well, we need an m and a b. So what is our, we don't really even need the b. We just need the m, because to find the equation of a perpendicular line, we just need to flip the m, take the reciprocal, and change the sign. So I'll show you what I'm talking about here in a second. Let's find this slope. How do you get from this point to that point? You go up 2 spaces and over 1. So the slope of the radius is simply +2 over 1. Positive because the line is going up to the right. 2 over 1 is our slope, and a perpendicular slope is called the opposite reciprocal or negative reciprocal. Basically, you flip that slope, so it's 1/2, and you take the opposite sign. Since that's positive, this is going to be negative. So here's our tangent line that has a slope of -1, 2. So basically, to get from here to the next point, you're either going to go down 1 and to the right 2, But we want to get to the y-axis because we want to figure out where does this cross the y-axis. So we're going to go up 1 to 6 and over 2, and boom, we're right on the y-axis because we were over at 2 already, 2, 5. So we're going to cross right there at 6, so that's our y-intercept. So our equation of the tangent line is y equals negative 1/2 x plus 6. So we really didn't need to know where the radius crossed the y-axis at. Like, we don't need to know the full equation. It happened to be at 1, but that doesn't really factor in. The only reason we needed the radius was we needed the slope of the radius so we could find the slope of the tangent, and then we just count over to the y-axis to get 6. So there's the equation of the tangent to this circle at that point.